Okay, hello, welcome back. So we define power to be du dt, time derivative of work. And by using this concept of power, we reintroduce the notion of time back into our energy domain. So a few remarks left I want to mention. First, let's do a bit of manipulation. You can immediately see that if you want to go the other way around, work from one point to another becomes integral of p dt. Well, your power could be function of time from one point to another. Or let's call it t1 to t2. But in other words, work is essentially accumulation of power. If you know the power, how it's changing with time, you can calculate how much work has been done by that source of energy. Another way you can think of power, let me write du again. Du, remember, was f dot dr. This was the definition. That is an ugly du. And now if I essentially divide this by dt. Oh, let me do this. dt. Does this work? Yes, it works. Oh, yeah. So on this side, I get power. On the other side, I can regroup this, write it as f dot dr over dt. And this one is f dot v. So if you want to calculate power of a force, you can calculate how fast the force is moving. And that should give you, at any instant, that should give you instantaneous power. So to remind you, U is how far force is moving. P is how fast force is moving. It is directly related to the speed, and you can make it makes sense if a force is moving a lot faster, it is doing work at a shorter time, and that means it has higher power. So that's that. This is extremely useful. It comes in many different flavors. For instance, without going into much detail, when you're talking about rotary system like electric motors and engines, a similar equation you can calculate. It is torque times angular velocity. Also gives you power. And it is very easy to, if you know the power of the motor, you know the rated speed, you can go to rated torque and so on. But don't worry about this for now. Okay, what else? Power is also a scalar. Very useful, so you don't have to worry about vector calculations, like when you were doing work and energy. You can also add powers of different pieces, different actuators and energy sinks in your system, and see how much total power in or out of a system is. Let me see. I don't think I have anything else in the remarks. So let me box this. I box that. Power is a scalar, and unit, we discussed it, is watt. It's a big W. And yeah, I think that is all I have for power here. There is a little bit left of this chapter. We cover it in the next video.